Hi students, today we're going to be learning more about probability. The purpose of this lesson is to be able to calculate the probability of different events involving or, and also find the probability of complements. Let's begin with a warm-up. So number 1, name the 4 suits in a deck of cards. So when you look at this deck of cards here, these are clubs. The next one, these are spades. We've got hearts. And we've got diamonds. Number 2, how many cards are there total without jokers? So without jokers, there are 52 cards total. How many cards in each suit? So look across at these clubs here. If you count them, ace, 2, 3, 4, 5, all the way up to king, there are 13 cards in each suit. And number 4, how many of each card in a deck? So if you look across, say these 5s right here, there are 1, 2, 3, 4. So there are 5 of each card. Or there are 4 of each card in the deck. Okay, let's go ahead and begin with some examples. So first it says you can think of probability as a fraction or as a percent. So let's see the following examples. Number 1, the probability of getting a 2. So imagine you're holding in your hand a deck of cards, 52 standard cards. What's the probability that when you draw one out of there, it will be a 2? So think of what we have here. So looking at our deck of cards, looking at how many 2s there are. So there are 1, 2, 3, 4. So there are 4 2s in a deck of cards. So the probability of picking one of those out would be 4 out of 52. So we write that as a fraction. So always put the total number of cards on the bottom and the chance or the probability of picking that on the top. So the probability of picking 1, 2 would be 4 out of 52. Depending on how the question is worded, you can leave it as a fraction. Always reduce it to lowest terms though. So 4, we can divide those both by 4, so that would be 1 out of 13. Sometimes it's better to write this as a percent. So doing that, we can use our calculator and put in 1 divided by 13, which is 0.0769. So when we move that twice, that's about 7.7% here. So the probability of getting a 2 would be 1 out of 13, or around 8%. Okay, let's go to the next one. The probability of getting a black 5 or the queen of spades. So again, imagine you're holding this deck of cards. There are 52 cards in that deck. The probability of getting a 5, so look at how many 5s there are. There's 1, 2, 3, 4, would be 4 out of 52. Or the probability of getting the queen of spades. So look at the queens here. The queen of spades, there's only one queen of spades. So we would just add the probability of getting that queen. So now the total, so what's the probability of getting a black 5 or the queen of spades would be 5 out of 52. We can just add those together. And again, always reduce to lowest terms. If they want this to be written as a percent, just divide that fraction. So 5 divided by 52. We get 0.096. So that would be 9.6%, almost 10% probability of getting a black 5 or a queen of spades. Oh, and now that I look at it, it says a black 5. It looks like I made a mistake here if you didn't catch it yet. For the black 5s, there's actually only 2 black 5s. So I need to go and change this because this needs to be 2 out of 52 because there's only 2 black 5s. So that's going to change our probability here. So let's fix this. So we have 3 out of 52. And when we divide that, 3 divided by 52, is 5.7%. Okay, that seems a lot better now that I reread the question. And number 3, the probability of getting a card less than 6. So a card less than 6 would be the probability of getting a 5 or a 4 or a 3 or a 2. We're going to count as aces high, so we can ignore this column here. So this would be the probability of getting a 5 or 4 or 3 or 2. So adding that up for the 5s, there's 4 5s, so that would be 4 out of 52. And getting a 4 would be 4 out of 52. Or 3 out of 52. Whoops, sorry, 4 out of 52 or 4 out of 52. And we can see the total here. It's these cards here. So 4 5s, 4 4s, 4 3s, and 4 2s. Adding those up, we get 16 out of 52. We can reduce that to lowest term, so if we divide those both, let's see, we can divide those both by 4. We'll start with that. And we would get, so if we divide by 4, we'd get 4 out of 13, which looks like the lowest it can go. And then as a percent, let's type that in here, 4 divided by 13 is 30.7%. So that's a little higher since we have the probability is a lot higher because there's a lot of cards that we could draw out of that deck. And remember, we're only trying to choose one. We're not trying to get all of these cards. It's just the probability of choosing one of those cards, and the card if it happens to be a 5, 4, 3, or 2. Okay. And as our general rule here for OR, make sure you're writing this down. OR means addition. So anytime you see that in probability, make sure you're adding those up. For the complement. So the complement of an event is the event not occurring. So the probability of A, written this way, just means the probability of A. And you can see here how we have the notation for the complement, showing this little tick mark or this little C for complement or this bar on top. Okay, so let's think about this one more time. So for event A would be drawing an ace. So thinking about this using a deck of cards, just drawing an ace would be 4 out of 52 because there's 4 aces in that deck of cards. Which reduced to lowest terms, that's 1 out of 13. And I think we had that over here, which was 7.7%. So that's the probability of drawing an ace. What's the probability of the complement, of not drawing an ace? So again, you can read this as the probability of not drawing an ace because we want the complement. So looking back at our deck of cards on this page, so let's bring this over so that we can see it here. The probability of not getting an ace. So basically what we want to do is count all of the cards that are not aces, or we can just subtract those aces out. So if there's 52 cards total and 4 of them are aces, really all we need to do is subtract out those 4. So 52 cards, we're going to subtract out those 4 aces because we are not getting those. And we would end up with 48 cards to choose from. So the probability of not getting an ace would be 48 out of 52 because 48 cards are not aces. Some people like writing it this way. They just take 1 representing 100% and then subtracting out the cards, that event occurring. And that event occurring, like we saw, would be 4 out of 52. So 1 could be represented as 52 out of 52 minus 4 out of 52, so we get 48 out of 52. So we need to reduce this to lowest terms. We can do that, and we can also get the percent. So 48 divided by 52 is 92.3%. And I'll let you guys reduce that to lowest terms. So it's a very high chance that when we draw a card out of the deck, it will not be an ace. All right, students, you guys go ahead and try these 3 examples, and then I'll see you in class tomorrow.